All right. Okay, hey everyone. What's happening? I'm just finishing the setup of all the different panels. So right, we've got Twitch up and running, Facebook is up and running, and YouTube is up and running. So hey everyone, my name is DrWeez. Thanks for tuning into my channel. So today I'm kicking off the Galax GTX 1080 GPU power project. So some background on this. This is an idea that was born at the GOC finals in Thailand last year in November, December. Basically, typically at GOC you'd have a competition day and then you'd have a world record day. So this year was a little different in that I think it's because of the venue and because of the different being in Thailand instead of being in Wuhan in China. We didn't have the competition day, but before the competition there was a bit of discussion going around. Maybe we can still have a world record day, maybe we can still do something. So one of the ideas that floated during that discussion was using a mining board or a 6-channel motherboard and 6 GPUs to go after the GPU power world record. So that sort of like planted a little seed in my brain. Like with all GOCs, you have to buy the cards to qualify for the event, and then you get given cards at the competition day. So at the end of the event I ended up having 5 GTX Galax GTX 1080s. The major problem with them is that they're water cooled, so it's not a case of you can just plug 5 cards in, run them on air and see if it scales and see how it goes. So this is a project that I've been working on and I've been wanting to kick off probably for 4 months now. And I'm at a stage now where I'm ready to start actually getting this thing going. I've built a water tower, so I'm going to water cool all 5 cards. I've got a water tower, I've got a 12 volt pump which pushes I think 13 liters a minute or a sec. The specs I don't know, but basically I couldn't afford to go out and buy 3 D5 pumps and all that sort of stuff. So with my plumbing experience and a couple of other ideas I've had and talking to a few people, this is the solution I've come up with. So it's now a case of I'm ready to start putting all of the pieces together, start scaling up from 1 card to 2 cards to 3 cards to 4 cards to 5 cards, and actually see where it goes. So let's have a look quickly at the actual system that I got up and running and the hardware that I've chosen to use for this build, and then I can discuss some of my thinking behind it. I'm just going to quickly transition across. So I've got the machine up and running at the moment. On the test bench I literally got it working because what I want to do is I want to install Windows and just get the basics up and running, and then we'll actually run the tests for 1 card, 2 card, 3 card, and actually go through it step by step and see how it scales. So if we just transition across quickly, I'm just running mem test because I had a customer come back to me with some faulty memory, and really I'm using this opportunity in this build just to do some mem tests. There's nothing more to mem test other than I'm using this machine while we're talking about the build to run some tests. And unfortunately I've got to leave mem test running for quite a few hours. It's a real pain in the rear end, but that's what it takes sometimes to keep a customer happy. Just a reminder of all the different platforms, right? So this stream is coming to you on Facebook, YouTube and Twitch all at the same time. So I'm uploading my feed to a server which then splits it out to all the different channels. The trick with that is I need to monitor 3 different chat windows. So I have set up a Discord channel. I try and keep that open on one screen. So if you are on there you can try and chat to me there. Other than that I have got another window open with the Facebook chat. I try and keep that open to see what's going on there. Some people like to say hello during the chat on that. And then we've got the Twitch chat as well. Not always the easiest to monitor all of these chats, so if I do miss something I will get to it eventually in a gap and say hello and thanks for tuning in. Alright, so I've got a complaint that the sound is not great. So is it breaking up? Is it too loud? I did just put new batteries in my receiver, so it could be boosting the volume a little bit. I've just turned it down. Let me know if that's any better. Otherwise, I might need to make some more adjustments. Yeah, so I use a wireless transmitter, the same sort of like transmitter you'd use for stage productions. So it goes from the mic, sorry about that, to a little wireless pack, and I did just replace those batteries in that wireless pack. So it could have been, that could be the reason why the volume was a bit louder, because I was doing some recordings earlier and I did have to boost the volume a bit. I do apologize. Thanks for the feedback. So let's go ahead and have a look at the build. And okay, so that's the first pass of mem test done with no errors. So we'll just escape that for now, so that I can rotate this machine around a bit and you can see what's going on. Alright, so what I've got for the main part of the build, let's just get the commentary back here, is the backbone I'm running is the MSI Z170A Pro Carbon. Alright, so that's this little bugger here. The reason why I chose this board is mainly because there are a lot of miners out there using it 7-card configuration. So if I'm wanting to scale up as far as 7 cards, I can do that with this. The other reason why I chose the Z170 over the later models like the 250 BT from BioStar or something like that, well, I don't have any of those in stock, and plus I've got a ton of Skylake processors still from my overclocking competitions, so there's still quite a few of those. So I can then also, if we're wanting to take this experiment a little bit further and test it with a K or non-K, or yeah, I've got options when it comes to Z170. That's basically the bottom line. In the board at the moment, I have got a Intel Core R, I think it's just the Intel Pentium 6300 or Intel Core R3. No, it's not a Core R3, I don't think. I think it's just a straight Pentium 6300. There again, it's just a chip that I had that I thought I'd start with on that. As far as the memory goes, I am using just straightforward, cheap and nasty 2133 memory, and the reason for that is because these were returned to me from a customer and I need to give them a test. So they will probably change to Galax memory later on. As far as the powerhouse is concerned, for this project I've selected the Antec High Current Pro 1300 watt power supply, and the main reason for that, and I wanted to use these power supplies for that project, is because of this beautiful little cable here, which is the link cable. So instead of having to use a switch on different power supplies and then use cables to connect them, by default Antec offer a link option. So this plugs into the back of power supply 1, back of power supply 2, and by default when you switch the one on, it switches the other one on. There's no MacGyvers needed to be made. By default it supports it. So yes, the motherboard is the MSI Z170 Pro Carbon, and then for the video cards, obviously we're going to be using the GOC what you would call it 1080 Ti's. Okay, so this is the only one I've got with an air cooler. You can see the retail product actually comes with a little display in the top here, and if we just transition across, the display is normally in the top here with LED, and you can program it and it gives you temperatures and all that sort of stuff. The engineering samples that we got at the event obviously didn't have any of that fanciness, and then they come bundled with water blocks, and I'll just get one out of the box here quickly so we can have a quick squiz at it. So I actually haven't gone as far as mounting one of these water blocks yet. That all now will come once I've got the windows ready and I've got the water tower ready. So it's quite a beautiful little water block. Bits power if I'm not mistaken. So no EK products here unfortunately, but it's a really well built block, and yeah, I'll show you the water tower configuration that I got. That's quite exciting. So that's this build in a nutshell. So what I want to do is I want to just update the BIOS, because for this board you will need to run BIOS equal to or greater than version 1.7 to enable more than, I think, 5 video cards. And then when you install Windows, you must have 4G encode enabled. Otherwise, you're gonna have some bad times when you're trying to get more than 5 cards up and running. Yeah, so I think that's about that project wrapped up in a nutshell. The scalability of this project, the things we wanting to check is how much of an effect does CPU really have on GPU power, if at all. The guy that programmed it says it doesn't have any effect. And then how far will it scale? Will it scale up as far as 7 cards? So I've only got access to 5 1080 Ti's at the moment, but if we find we scale up to 5, I'll make a plan and I'll invest in 2 more and see how far this can go. It's a project that I've been very excited about, to be honest, and I'm glad to see it's finally kicking off. So let's go ahead and just transition that across and have a look at how I've got this all installed. So on the test bench here is an open frame. This is typically what I would build for my customers that are building mining rigs or something like that. Really straightforward, nothing fancy, made out of 38 by 38 wood, what we call in this country brand ring. This is I'd say my revision 4 of the frame, and the unique features of this one is a vertically mounted motherboard. So the board is actually mounted upright at the back here, and I'm battling to get a good view on this, so maybe that's a bit better. Yeah, so the motherboard is mounted at the back here. Your GPUs, multiple GPUs, are mounted then underneath the video cards, and then you just rack up 1 2 3 4 5. So this is slightly smaller than what I would typically build for like a 6 or 8 card rig, but being water cooled, it's going to work out quite well. And the main reason for this design of having the vertical motherboard and stuff like that is for the last project that I did, where I rolled out, I think it was about 35 of these machines to a customer. We actually built custom towers where basically the airflow was controlled from below and extracted above. So there's only one way for the hot air to go, and that is the reason why we ended up going with the vertically mounted motherboard rather than horizontal. The other reason why it works out nicely for this project is because if we end up with a water leak of some sort, hopefully it just leaks down instead of down onto nothing, rather than down onto the motherboard or onto the PSU or something to that effect. So yeah, it's sure it will still go onto the PSU with this build, but we'll worry about that when we start getting the 5 cards up on the water cooling. And I think that's about the introduction of that done. I'm going to go ahead and just continue to test this memory for the client. I need to give him feedback by tomorrow. The stream is done. The next step for this build is to get the water tower into the OC lab. Very basically, I can draw you an image, and if you hit up Google, you'll be able to see what I've done. I basically copied a guy on overclock.net. So if I get, I'll just get the book across to here, and then I'll transition across there again. Let's just have a quick look at the chat. So Facebook, we got Extreme Addict has joined in. How's it, dude? Long time no see. What's happening? Suzuki, hey man, how you doing? And Mr. Pino, thanks for tuning in. How's everyone doing? Right, so let's have a look. The basic concept of what I've done with the water tower, right? It's I hope you can see this now. Okay, you can see here nicely. So I've got a container. I'm going to draw this upside down so you can see. So I've got a container. It's a 75 litre bucket basically, and in the container I've got 110 mil PVC piping, and that will go up like that, and then I put a V in there, right? You can actually see nothing there, so let me draw it out, and then I'll show you on the screen here. Okay, so 110 mil piping, and really just remember, I'm no artist, I'm not an artist. The idea is, alright, so let's have a look here. So got 110 mil pipe. The idea is that where I've got the arrow here, I've got a fan which blows cool air in, and then at the top over here is where the water will fall. So it's basically the same concept as a cooling tower. So I think the overclock.net guy used this as a bong cooling tower or something to that effect. So the idea I had was, right, I've got 5 cards generating heat. How am I going to dissipate that heat in the volume of water or the volume of coolant? And you know what, to put a series of 360 rads or even greater than that, like 480s or something like that, all it will do is just add extra resistance into the line, meaning I'd need more pressure or I'd need more power to move that volume of water. Already 5 water blocks is like, it's going to be crazy the amount of resistance in that line. So what I thought of, well, the best thing we can do is have a larger reservoir, larger volume of water, and then use the same technology that that is used out there for like cooling systems, stuff like that. So you just let the water fall against the moving air, and then evaporation takes place, and what is left is a cooler product. So you do have a little bit of evaporation and a couple of things like that, but we'll see how it goes. Like I said, this is just a project that was dreamed up or was discussed at the GOC finals last year, and then just my mind's just been working on it ever since. And you know, there's nothing else I can really do with these 5 cards other than some exciting project, because it's not worth my reputation and selling them and something goes wrong with them, no warranty, stuff like that. Engineering samples you really just got to hang on to and do fun projects with. So with that being said, we'll start off with one high current pro. We'll get 2-3 cards running off one power supply, and then we'll introduce the second power supply, which I'll then just mount on the other side of this open air frame. And yeah, I think we should start seeing some actual benchmarks hopefully on Thursday. I think we'll carry on with this on Thursday. I've already built the water tower, so it's ready to rock and roll. Just got to get into the lab and see how it runs. But yeah, so that's the introduction on that project. I'm going to see, yeah, I think Thursday afternoon we'll do another session, and we'll carry on from there. Alright guys, so just a reminder to sign up to or follow me on Twitch so you get notification of when I go live. Also you can follow me on Facebook if you want to get updates of what's going on, and don't forget I've also got that Discord channel up and running now. So I'll just finish off with that and say, yeah, happy benching, and until next time, we'll see you later. Yeah, okay. Yeah, it's 3 o'clock, definitely. Okay, alright guys, until next time, happy benching.